Welcome to my classroom. In this video, I will redo two problems I discussed in my previous videos on mass point, but I use another technique to solve them in an even faster way. I call this technique as elastic line, in contrast to mass point. This question is the example 2 in my 17th video, mass point further 1. I solved this problem with three different methods: ratio of areas, mass point, and similar triangles. You may check it back later for a comparison. The answer is BG to GD equals 6 to 17. I'm going to solve this question by the fourth method, which is much faster than solved by ratio of areas and faster than mass point or similar triangles. The idea of this method is to imagine the lines are elastic and to press the figure to form a line so that the ratio can be obtained in an easy manner. Since we want to find the ratio of BG to GD, press the parallelogram so that the points F, G, and E are coincident, and the figure is deformed to a line with the endpoints B and D. As the line segments BF and BE are supposed to be overlapped, and in order to calculate easily with the numbers from the ratios, let us change the ratios so that BF and BE share the same numbers. By using the LCM of 2 and 3, that is 6, the ratio of AE to EB is rewritten as 3 to 6, and BF to FC is 6 to 8. So DC is 9. From the line, we have BG to GD equals 6 to 8 plus 9, that is 6 to 17. The answer is same as what we obtained before. This problem is example 2 of my 18th video, mass point further 2. The problem was solved by mass point. The solution is not complicated but not simple. Let me redo it by elastic line. Like the solution by mass point, split the figures into two cases. Find the ratios of dP to PG and dQ to QG. Then combine the results to get the required ratio, dP to QG, which is 14 to 11. I demonstrate the use of elastic line twice with this example. Let me start with figure 1 for the ratio dP to PG. To get this ratio, press the triangle such that the points F, P, H are coincident, and the triangle is deformed to a line with the endpoints A and C. Mark the points D, B, and G on the line according to their ratios. As AH to HC is 2 to 4, and BF to FC is 1 to 4, and HC equals FC on the line, put 4 for this part. And A to the common point FPE is 2. As FG to GC is 3 to 1, the total is 4, so mark G 1 unit from C, or 3 units from the common point. For the other side, BF to FC is 1 to 4. Mark B 1 unit from the common point FPH. So 1 unit is left for A to B. Since AD to DB is 2 to 5, mark D 2 over 7 units from A, or 5 over 7 units from B. Now, the line diagram is done. From the diagram, we can see the ratio easily. That is, dP to PG equals 5 over 7 plus 1 to 3. that is 4 to 7, same as my previous solution. Use figure 2 for another ratio, dq to qg. I hope you already get the idea of doing so. Press the triangle such that E, Q, K are coincident and the line is formed. This time, the endpoints are not A and C, but A and B. Why? Look at the ratios, pause the video, and think about it first. From the ratios, AE to EB is 5 to 2, and AK to KC is 5 to 1. AE and AK refer to the same part on the line. Both go to 5 units. Then EB is 2 units and KC is 1 unit. That is, EB is longer than KC, so that B should go further than C from the common point EQK. That is why the endpoint is B, not C. Mark D, 2 units from A or 3 units from the common point. On the other side of the common point, mark C, 1 unit from the common point. As BG to GC is 4 to 1, mark G, 1 over 5 unit from C, or 4 over 5 unit from B. From the diagram, we see that dq to qg is 3 to 1 plus 1 over 5. That is 5 to 2. Combine the results. dp to dg equals 4 to 11, and dg to qg is 7 to 2. We have dp to qg equals 28 to 22. That is 14 to 11. The answer is same as what we obtained before. I suppose this idea is new to you, and it takes some time for full understanding. You may redo the examples in this video and some others in my previous videos, so that you can check the answers easily as a consolidation of this technique. I used the term elastic line on my own, and not sure if it is a proper term. I just explored these techniques after mass point. I think the term elastic line tells some idea of the method, so I use it. I hope you agree with me that this method is interesting and useful, particularly during competitions for answers only. We can find the answer much faster than other methods. Yet, if it is an exam question of conventional paper, you are not expected to use it, as the marker is not likely to understand your solution. Anyway, this technique is good for fun, right?